Okay, so today we need to discuss about the NSG algorithm, and we will solve one example, and also we will understand how this example will follow the steps which we have studied for the NSGA fitness assignment. Okay, so we consider two multi-objective functions for this problem, and these functions are one function is f1 function over defined over one variable. Okay, so x1 variable is only there here, and it is equal to x1 only. So the value of this fitness function is the value of the variable itself. Then we have another variable, another objective function, that is f2, which is defined over two variables x1 and x2. And here the definition of this function is 1 plus x2 upon x1. Both objective of these fitness functions are to minimize the fitness value, and the bounds of these variables are given as 0.1 to 1 for x1 and 0 to 5 for x2. So these are two objective functions. That's why we can apply here multi-objective optimization algorithm. And today we will discuss about the NSGA, that is non-dominated sorting genetic algorithm. Okay, so the first step of this algorithm is to initialize some variables which is required in our algorithm. Okay, so the first variable is, let me show you, this is the step one, you can see in the PDF. We need to choose the sigma share value. Okay, so this is application dependent. Actually, sigma share is application dependent, and it is given, it should be selected by user. So here we consider the sigma share value as 0.158. Okay, this is the sigma share value. Then we need to choose the a small value for F channel, and it is, we have selected here 0.22. Okay, and that's it. These are the two parameters which need to be initialized before starting of the algorithm. Then based on these values, first we need to initialize our first step is to initialize the fitness value, and the fitness value is f min is equal to the number of solutions in the population plus epsilon. Okay, so for that we need some defined population. So in this example we consider these solution values. So we consider only 6 solution values, and these are the randomly selected solution values for x1 and x2. Okay, so like for solution 1 the values are 0.31 and 0.89. Similarly we initialized 6 solutions. So the value of capital N is 6. Why? Because we have initialized 6 solutions. So the fn value would be 6 plus 0.22. It means it is 6.22. So this is our f min value. So this is step 1. We initialize some of the parameters required by the algorithm. We initialize the f min value, and also we start a counter j is equal to 1. Okay. Now in step 2, we need to divide the algorithm into different fronts actually. Okay. So, and how we can divide into different fronts? By applying the non-dominated sorting algorithm. So you can see here, need to classify the population into different non-dominated sets, and it is observed that there are 3 sets. Okay, we already solved this problem previously, and because you can solve it again, but I just write directly how we can, what are the different fronts which is formed after applying the non-dominated sorting. Okay, so in P1 front, first front, 3 solutions are there, 1, 3 and 5. Then in P2, 2 solutions are there, 2 and 6. You can watch the previous lecture videos how we to see how we can calculate these fronts. Then in P3 only one front is there, that is one solution is there, that is solution number 4. So these are the 3 fronts based on the values which is sliced in this table. Okay, so we have 6 values, and based on the 6 solutions, And based on these solutions, we have also calculated the fitness F1 and F2. F1 is equivalent to X1 only because this is our definition. F1 is equivalent to X1 and F2 is calculated by this formula. So we have F1, we have F2. Once we have the fitness value, we can divide the population into different fronts. Okay. Any question? Okay. So in step 2, the population is divided into 3 fronts in this example. Now, the next step, that is step 3, we need to assign the fitness now. Okay. So from here itself, the NSGA fitness assignment algorithm is going to be applied, which we have discussed in the last lecture. And in this algorithm, the first idea is to assign the more fitness values to the first front solutions and less fitness values to subsequent fronts. Okay, so the first front is front 1, and the fitness which is assigned to front 1 solutions is equivalent to n. Okay, so we have 6 solutions. We need to assign these 6 fitness values to the solution of front 1. So the F1 is equal to n is equal to 6, means the solutions which in the first front, that is solution number 1, solution number 3 and solution number 5, these solutions are assigned the fitness values as 6. You can see in the table, the solution number 1 is assigned as fitness value 6, then solution number 3 also assigned 6 value, and solution number 5 is also assigned as a 6 value. These are the assigned fitness values based on the solution count. Okay, now once the fitness for the first front solutions have been assigned, we need to, because we need to care about the crowding distance also in the NSGA. So the solutions which are very less crowded need to be emphasized more to maintain the diversity. This is the idea. So for calculating the crowding distance, we need to calculate the niche count and we need to assign the sharing fitness value. So sharing fitness, shared fitness is the actual fitness which need to be assigned. Okay. So now the next step to calculate the shared fitness value. Now for the calculation of shared fitness value, first we need to calculate the distances within a same front. Okay, solutions. So in a first front, only 3 solutions are there. So for calculating a distance, there is a defined formula. I just write the formula, and based on that, we can assign the fitness values. So Dij, the distance between solution I and solution j, is equal to under root summation of k is equal to 1 P1 if I am talking about the first front. If I am talking about the first front, this can be changed. ये front wise आपका change होगा. So k is equal to 1 to number of solutions in that front. We need to sum it up the calculated values here. So xk of ith solution minus xk of jth solution divided by x max of kth front minus x mean of kth front to the power 2, that is whole square. So by this formula, we need to calculate the distances. So for first front, we need to calculate the values for D13, distance between solution 1 and 3, solution 1 and solution 3. Then we need to calculate distance between solution 1 and 5, and then we need to calculate distance between solution 3 and 5. So we need to calculate 3 distances for front 1. So for D13, I can put here D13 is equal to, okay, what are the values? How we can calculate this one? So D13 is equal to under root. So it is a two-dimensional problem. Okay, we have only two dimensions here. So only two times we need to sum it up. So xk1. So for we already calculated this I is equal to 1 and j is equal to 3. Okay, so this value xk. So you look in the table. This for solution 1 it is 0.31. Okay, and then we need to pick the value for another front because j value is also picked up. So it is 0.22. So it should be like this: 0.31 minus 0.22 divided by the maximum value. Maximum value is 1 minus the minimum value to the power 2 plus again for the second dimension 0.89 minus 0.56 divided by the maximum value 5, minimum value 0 to the power 2. Okay, so by the calculation of this, D13 would be 0.119, or we can say that it is 0.12. So we assign the D13 as 0.120. In the same way that we have calculated here, in the same way we can calculate D15 and D35. So for D15, I am directly writing the values now. For D15, it is 0.403, and for D35, it is 0.518. So these are the distance values that we have calculated for the first front. And in the first front, we have only 3 solutions. Okay, now once we have calculated the distance, based on that, we need to calculate the shearing fitness value. And the formula for the shearing fitness value, the shearing fitness for some front Dij or whatever distance we need to pass in it, it is equal to 1 minus that same formula that we have studied. It is 1 minus d upon sigma shear whole square if d is less than sigma shear. If d is less than sigma shear, then only we apply this formula, otherwise we assign 0. So we have the value for d here, we have the value for sigma shear here. Okay, so we can easily check that where the condition d is less than sigma shear hold. We need to check about whether d is less than or equal to sigma shear. So in the first case, in the D13, so d is less than sigma shear. So wait a second. I think it should be greater. We need to check about whether d is greater than sigma shear. Okay, just a second, I just verify it. Okay, no, this is okay. D is less than. If d is less than sigma shear, then we need to follow first condition. Otherwise, we need to follow second condition. In first case, this 0.120 is less than the 0.158, means d is less than sigma shear. Condition true. It means we need to assign the fitness value by this formula. So we need to assign 1 minus the value of D 0.120 divide by sigma share value 0.158. Okay, and sorry, to the power 2. So after the calculation, the sharing fitness value is 0.423. So I'm directly writing this thing. Directly write it. So the sharing fitness value over D, if D is equal to this, the sharing fitness value for D13 is 0.423. And here, because these D values are greater than the sigma share value, the sharing fitness values are 0 in both cases. Okay, so this is the sharing fitness value. Now the next step, क्योंकि अभी आपकी शेयर फिटनेस नहीं निकली है, ये केवल शेयरिंग फंक्शन की वैल्यूज आई हैं, ठीक है. So we calculate the sharing function values, we have calculated the distance. Now the next step is to calculate the niche count. Okay, so for calculating the niche count, हम क्या करते हैं, we need to add the these values, that is sharing fitness values. Okay, just a second. So for calculating the niche count, NC1 for solution 1, niche count for solution 1 is equal to, look at the book, it is equal to sharing fitness value, sharing function value of D with itself, इस solution की अपने से sharing function value, plus sharing function value of D with third solution, मतलब इसी front के बाकी solution से sharing function values, and sharing function value of D with fifth solution. So we need to add the sharing function values with itself and with other solutions. Always the sharing function value with itself is 1. Okay, so because there is no need to share the fitness value with itself, so the value for D11 is 1, the value of D13 is 0.423, and the value of D15 is equal to 0. So this is equal to, when we calculate it, so you can see in this book 1.423 is the value. Okay, so this is a sharing function value for NC1. But for first solution, we have calculated the niche count. Okay. Now, similarly, we need to calculate the niche count for third solution, क्योंकि front 1 के अंदर P1 के अंदर 3 solution है, पहला, तीसरा और पांचवा. So we need to calculate the niche count for first solution, niche count for third solution, and niche count for the fifth solution. So niche count for the third solution is equal to the niche count for D sharing function value from 3, 1, means what is the distance between 3 to 1. So remember always, distance between 1 to 3 and 3 to 1 is similar, but yes, we can write it like this: 3 to 1 plus sharing fitness value with 3 to 3 plus sharing function value with 3D 3 to 5. So which is equal to sharing function value from 3 to 1. 3 to 1 and 1 to 3 are same case. Okay, so we can write it like 0.423. Now second is 3 to 3. For 3 to 3 it is 1 plus for 3 to 5. For 3 to 5 it is 0. We have already calculated for 3 to 5, it is 0. So now when we add it, it is like 4 to 3, 1.423. For solution number 3, the fitness value is 1.423. Similarly, for another solution, solution number 5, we need to calculate the fitness value for third solutions also. So for solution number 5, we need to calculate the sharing function value for the in the same case D5 and 1 sharing function value for 5 and 1 plus sharing function value for 5 and 3 and sharing function value for 5 and 5. So for 5 and 1 and 5 are same thing. So 0 plus 5 and 3 and 5 is same thing. Again 0 plus 5 and 5. 5 and 5 is the sharing function value with itself is always 1. So sharing function value with itself is here we have to write as 1. So this is a niche count for solution number 1, solution number 3 and solution number 5. For solution number 1 and 3, the niche count is same 1.423, and for solution number 5, the niche count is 1. So this way we can calculate the niche count. Now for the next step, we have calculated the niche count now. So after niche count, we need to assign the shared fitness value. So shared fitness value is assigned based on the niche count only. Okay, so previously for first front solution, the fitness which is assigned is 6, 6 and 6 for solution number 1, for solution number 3 and for solution number 5. All these solutions have the same fitness value. Now after calculating the niche count, the sharing function value, that is the assigned shared fitness value, would be 6 by the niche count for solution number 1, that is 1.423. The niche count for solution number 2, 6 by 1.423. And the niche count for solution number 5, that is 1. So which is equal to 6 by 1.423 is equal to 4.22. So we have assigned the 4.22 to solution 1. Similarly, 4.22 to solution number 3 and 6 value to solution number 5. Okay, so solution number 1 and 3 is assigned as 4.22. So this is a fitness assignment for the front 1 solutions. Now we need to update the F mean also. So in step 4, let me rough the above step 1 and write it here, step 4. So in step 4, what we need to do, we need to update the F min, and the F min is the minimum value in the previous front solution. Okay, so what is the minimum value? It is 4.22. So F min is updated, and then we need to set the counter j is equal to 2, that is previous j plus 1. Then again we need to apply the same procedure from step 3 onwards. We need to apply the same procedure for the front 2 solutions. Now front 2 contain only 2 solutions, that is solution number, you can see in the table, for the front 2 we have 2 solutions, solution number 2 and solution number 6. So solution number 2 and 6, here you can see here, so solution number 2 and solution number 6. Okay, and the updated fitness value is now 4.22. Again we need to calculate what we need to first we need to assign the fitness value to these 2 solutions. So solution number 2 and solution number 6, the fitness value is F min is this, and we need to assign the fitness value as F min minus epsilon. So both have assigned 4 as a fitness value, 4.22 minus epsilon. Okay, so once this is assigned, then this is your F2 values. Now we need to calculate the F2 dash, and in order to calculate the F2 dash, first we need to calculate the niche count for solution number 2 and niche count for solution number 6. And in order to calculate the niche count, same procedure is need to be applied. Okay, so I hope you have understood how we can calculate the sharing fitness value. So this table will show you. So these are the front IDs. These are the assigned fitness like 6, 4, 6, and 3.78 for the next front solutions. So these are the assigned fitness values that we have calculated here, and we calculated here. These are the assigned fitness values, and then the shared fitness values is calculated based on the niche count of each solution. So these are the shear fitness values after computing the algorithm over these solutions over all the fronts. So we have only 3 fronts in this example, so we can assign like this only. So this way the solution or fitness values can be assigned, and this is a final plot after assignment of the fitness values. And once these solutions have assigned the shared fitness value, it automatically considered the diversity, because the less crowded solutions have assigned the more fitness value. You can see here the solutions which are less crowded. One second. Like here, this is a less crowded solution in this front, so it is assigned at 6 value. In second front, both are means same thing, so 4 values assigned, and third front obviously comparatively lesser fitness values as compared to their superior fronts. So in this way, the shared fitness values assigned. When you applied the selection and crossover and mutation operator of genetic algorithm over these fitness values, obviously the solutions which have the bad or the worst fitness values will be rejected, and the solutions which have the higher fitness values will be accepted. Okay. So the time complexity is similar, because most of the time the time which is required in the non-dominated sorting procedure, and we know that for non-dominated sorting it is order of mn square, and this is a most time consuming operator for this type of algorithms, because it need to be, we need to divide the all the solutions into different fronts, and this is a main step. After this, we need to just calculate the sharing fitness value and niche count. So the sharing function implementation requires every solution in a front to be compared only. So if we have row solutions, row fronts, and then there are total within a front, because if 2 or more solutions are there, distance computations require this much of time complexity, and we can assume that this is order of n into n square. Okay, after the computations of the within a front solutions for computations of distance vector, that is by this formula. So the overall complexity is larger of order of mn square and order of n square. So whatever larger is there, it can be a time complexity, because there are 2 main operations. First operation in step 2, where we need to divide the solutions into different fronts, and the second step is to compute the distances. So in दोनों में से जिसकी भी complexity ज़्यादा होगी, it can be considered as a time complexity of the complete algorithm. Okay, so that's it about the NSGA algorithm. Now I think you have cleared about this algorithm. If you have any doubt, you can ask. And yes, that's it for the today's lecture.